Yo guys, yo guys again. Still under chapter 2. Now we're gonna talk about substitution. I want to say substitution. We did use it under chapter 1 when we were solving some equations. We had some interesting equations we were solving. That was where I was like, I remember in some problem, I had something like let y to the power of half be no, it was to the y to the power of 1 over 4, let it be k. I had something like this, and then the next step where I saw this guy, I substituted k, right? So it's something we're going to do right now. The importance of this thing is that, remember, when you are solving problems, you don't want to create more problems while solving your current problems, right? You need money. Just an example. You need money, and you want to make, let's say you need money. Then you realize that if you get pregnant, and the father of the kid is not working, and you're not working as well, you become eligible to get like grant, which I think at the moment is like 500 rands. So you then decide to go and become pregnant and have a baby, and therefore be able to get the money. Yes, you have a problem, you don't have money, but now you are creating yourself more problems while trying to solve the problem of money, which is gonna be problematic. It's gonna be problematic because you're gonna need more money after you've introduced another person on earth. So that is just a slight example about the whole thing of substitution. It is going to help you not to create more problems when you are solving other problems. Like here, we have this problem right here. We have to solve for x, and while we are solving for x, we realize that, look at this bracket, ne? If you expand that bracket, you're gonna have x to the power of 4. I'm not sure what's gonna be the coefficient, but you're gonna have like x to the power of 4. Now imagine you have x to the power of 4, x to the power of 3, x to the power of 2, x to the power of, in one equation. At the moment, we haven't covered that section yet. And I don't think we actually do. I think, do we actually do? Yeah, I don't think in grade 11 we do that. So yeah, we're gonna use this concept of substitution to help us with such problems. So now what's happening? You realize this and this, they are the same thing, right? So you can say let x squared plus 5x be k. I love k. So now we go, you say you have minus, I'll go with the black, minus 24, 10, you have k plus k squared. We can just transpose 24 plus 10 here, and then plus 24, right? You have 0. Trying to solve this with my method of factorization, and also, guys, so you don't have to always use that method, but that method is the best. Like, if you don't want to overthink numbers, the method that I've been factorizing with is the best one to use. But if you can just be like, for example, in this situation, the coefficient of k squared is 1. So you can just say, what are factors of 4 that if I add or subtract, they're gonna give me what? They're gonna give me 10. You realize that 6 and 4, multiplying them together, they give you 24, and adding them, they give you what? 10. So you can just say you have k plus 6, k plus 4, and then you are done factorizing. You're basically done factorizing. But now, if you happen to not be able to do this, if for some reason you cannot do this, let's go with my method. You multiply 1 and 24, you get 1 times 24, that is 24. Factors of 24, that is 1, 24, 2, 12, 3, 8, 4 and 6. You want factors, a pair of factors that's going to give you the middle number, and it's this guy over here. So you have your k squared, I can say plus 4k plus 6k plus 24. Then I group them together. I mean, I can just group them here since everything is positive. Taking out the common factor here, it's gonna be k into k plus 4. I take out the common factor here, which is 6. I have k plus 4. So now I'm realizing I have a common factor of k plus 4. Another common factor is k plus 6, which is exactly what we had, Yeah, so remember, just go with the method that, makes maths easy for you. Doesn't matter which method you use, so long as everything is clear and you don't make any mistakes, you'll get full marks. So you still have your 0 here, so you can say what? K plus 4 equals to 0, or k plus 6 equals to 0, right? So now, I mean, we can just, say therefore k is equals to 4 minus 4, and then k is equals to minus 6. But instead, remember, we still have to solve for x, not for k. So just right here, I can just substitute my k's. Say I have x squared plus 5x plus 4, right, equals to 0. This side I have x squared plus 5x plus 6 is equals to 0. So you can do the same method of multiplying 1 and 4, find the factors, yeah, but I will just use the simplest one. I open my two brackets since the coefficient of x squared is 1. So I'm going to have x, I'm going to have x. I'm 1, 2 numbers, which if I multiply them, I get 4. When I add or subtract them, I get 5. It's 1 and 4, and the sign has to be positive. Right? And to solve it, therefore, x is equals to minus 1, or x is equals to minus 4. This side, I can do the same thing. 2 numbers, I multiply, I get 6. I add, I get 5. It's gonna be 2 and 3. The signs are positive, and therefore x is equals to minus 2, or x is equals to minus 3. Done. Then you are done solving this problem. Very interesting problems, I would say. Let's do the last problem on the substitution. I think we're gonna need a new page. So this one is x squared minus 18 plus x plus 72 over x squared plus x. This one is very interesting. Just pause the video, look at it, try to solve it, and yeah, let's do the solution together. Okay, so very interesting problem. So let's get into it. Right, so now something interesting I see right here. How do I draw those things? It's no let me see. It's yes, yeah, not a bad one. I have this, right? So here, the most interesting thing here is happening here. You can be confused of like what's going on, what is it that I'm gonna make it, how are you gonna maneuver through all this problem. But you see here, you have x squared, which is exactly what you have here. So you can rewrite this problem and say you have x squared plus x minus 18 is equals to plus 72 over x squared plus x is equals to 0. From here on, now you can say let x squared plus x bk, right? Yeah, bk, of which now after here we're just gonna say we have k minus 18 plus 72 over k is equals to 0. Now I want to eliminate this k, so the best way to do so is to multiply that fraction by k. But remember, laws of fractions, what you do on the left you do on the right. So I can multiply the whole thing by k. That means I'm gonna have k squared minus 18k plus 72, right, is equals to 0. So yep, since my thing, the coefficient of x squared is of k squared is just 1, I can have k here, another k, and then find the two factors of 72 that if I add them, if I add or subtract them, they give me minus 18, but if I multiply them, they give me 72. Right, so I can just say, 72, I have 1 and 72, I have 2 and maybe 36, I think. Yeah, let's see, 72 divided by 2, 36, say divide by 3. 3 is 24, and we still haven't got a pair that gives us minus 18, so let me say divide by 4, I get 18, and this pair doesn't give us 18 as well, so 5 doesn't go in, say 6, 6 and 12. But this pair I can just stop right here because I have a pair that gives me minus 18. If I have minus 12 and I have minus 6, product of this thing gives me positive 72, and adding them will give me minus 18. So I have them equals to 0. And then what do I have? Just k minus 6 equals to 0, or k minus 12 equals to 0. Since I still have an x to solve for, I can say I have x squared plus x minus 6 equals to 0, or I can say x squared plus x minus 12 equals to 0. Here doing the same thing, right? So I have x, x, and x. For this one, two numbers, I multiply them, I get minus 6. I add them, I get I add them or subtract them, I get 1. It's gonna be what? Positive 3 and minus 2. Alright, I multiply these two, I get minus 6. I add them, I get 1. Two numbers, I multiply them, I get minus 12. I add them, I get 1. It's gonna be plus 4 and minus 3. Right, so here I'm already saying that therefore x is equals to minus 3, or x is equals to 2, and then here I have x is equals to minus 4, or x is equals to 3. Wonderful. So yeah, this is how we use this whole thing of substitution. There are many other problems. Let me just give you this one just for interest's sake. Yeah, so this one you already see that these two guys here, they're the same. So you will do your let, and then you have k equals to k, multiply the whole thing by k, you get 9 is equals to k squared, and then you just from here it's 0, k squared minus 9, which is just difference of two squares, difference of two squares. Yeah, just a quick one. And then from there on you go again, solve your problems and you're done. So maybe just try to do that one. Yeah, we are done with this section. Now let me see, what are we doing next? We're gonna find some equations.